Exercise is 5-5. Okay, this denominator factors to x minus 6 and x plus 6. And according to partial fractions, if we get a linear factor, then the numerator, you put an a over it, and here's another linear factor, so just another constant over it. We should be able to re-express this as an integral of these two things if we can figure out what the a and the b are. Now, to get a common denominator, we would have to multiply, to add these fractions, we'd have to multiply this one by, come on, pen, x plus 6, and this one by x minus 6. And we have 2x, we have x's, the max we're going to get here, so we'll have x's and constants. And in the x's, to make this identically equal, this has 2 x's here. And so over here we'd have to have 2 x's. Well, we have ax's plus bx's. So a plus b must add up to be 2 if they're going to come out to be exactly 2 x's on this side. And the constant over here, there is no constant, 0. So that has to equal what we get from here. And to see, that would be 6a is a constant and minus 6b. So 6a minus 6b would have to equal 0. And I think if you look at this, you could see clearly that I could multiply this one by 6 all the way through, add these two, and the b's would drop out, and I'd get 12a equals 12. So a would have to be 1. And if a is 1 and a plus b is 2, b must be 1. So this is the integral of 1 over x minus 6 plus 1 over x plus 6. And we can split those integrals to two separate integrals. And 1 over x minus 6, if you were to do a u sub for x minus 6, then du would equal dx. And so you'd have 1 over u du, and that integral would be ln of x minus 6. That's the value of x minus 6. And the integral of 1 over x plus 6 would be ln of the absolute value of x plus 6 plus c. And these would be, in here would be 1 over x minus 6, and this one would be 1 over x plus 6, or vice versa. So that's the idea. Now, they said, what if we just did a w substitution for this? Well, then dw would equal 2x dx, and you could divide by 2x on both sides. And so this would become the integral of, 2x over, if we let w be that whole thing, it would be just w, and dw over 2x, and the 2x's cancel. So we just have 1 over w dw, which is ln w, our x squared plus or minus 36 plus c. Now, ln of this would be ln of x plus 6 times x minus 6. And remembering our log rules, if we have the log of two things multiplied, it becomes the log of the first plus the log of the second, which is the same as what we had up there. And that's what they want you to see. If you have a log of something plus a log of something, that just becomes the log of those two things divided. Or multiplied, I should say, because they're added. If they were subtracting, it would be divided. Okay? Number 2. Well, this would be the antiderivative of something over x plus 6 plus something. Those are both linear factors. And so we have to figure out the a and b. And it's 1 over here, and to figure that out, we'd have to multiply this one by x plus 8 and this one by x plus 6. There's no x's here, so for the x's we have no x's have to equal ax's plus bx's, so a plus b has to add to be 0. And the constant, over here it's 1, so the 8a plus 6b has to be 1. So, let's see, if I multiply the top one by, let's say, -6 all the way through, then added them, the b's would drop out, and I'd get 14a equals 1. So a equals 1/14, and so b must be -1/14. So the 1/14 comes out, so I get 1/14, the antiderivative of 1 over x plus 6, which is ln x plus 6. And we'd get -1/14 times ln of x plus 8 plus c. If we factored out the 1/14, we could also write this as 1/14 ln, and log minus a log would be divide, so it'd be x plus 6 over x plus 8 plus c. So we could write it that way too. Okay, number 3. So now they're not telling us what the partial fractions would be, and so we have to factor the denominator. And so that would be x minus 2 and x minus 1. So this would become the antiderivative of a over x minus 2 plus b over x minus 1 dx. And this one would be times x minus 1. This one would be times x minus 2. And so we would have x's, 8 of them here. So for the x's, we get 8 has to equal a plus b. And the constants, the 6 would have to equal minus a plus a minus 2b. If you just add those, the a's drop out, and we get minus b equals 14. So b equals minus 14. Oh, let me write that here. B is minus 14, and a would have to be, if b is minus 14, a would have to be 22. If I haven't made a mistake, let me check my arithmetic here. 8 would have to be a plus b, and 6 has to be minus a plus 2b, minus 2b. If we add up the a's cancel out, we get minus 1b equals 14, just adding them. Yep. And 14, if b is minus 14, a has to be plus 22 to get 8. Yes. So this becomes ln, see, A was 22, ln of x minus 2, B is minus 14, ln x minus 1 plus c. Now, since it's not the same coefficient, it's kind of hard to factor them out. You could put that up as a power. You could write this, be ugly, ln of x minus 2 to the 22nd power over, because it's subtract, x minus 1 to the 14th power plus c. But it looks a little simpler that way, so I'll leave it like that. Okay, well, they're telling you this is what the partial fractions are for 4, but how do we know that? Well, in this factors to be an x squared comes out and leaves you x squared plus 25. This doesn't factor, and this is x times x, so we have a linear factor. So we need an x and an x squared, because the linear factor happens twice, and that would have, since that's quadratic, you need a linear above it. So there's your a, b, and c, d. They chose to put the a over x squared. I probably would have put the a over the x and the b over the x squared, but it doesn't really matter. Let's see if we can figure out what this works out to be. So, okay, so we have a would have to be multiplied using what they have here. We have an x squared. We don't have this, so it'd have to be multiplied by x squared plus 25. The b has an x. It needs another x and that, so it's going to have to be multiplied by x to the third plus 25x. And the cx plus d has all of this, so it just needs an x squared. So I'm going to have my highest power is going to be x to the third, which is what I have here. So I'm going to have x to the thirds will give me the equation 9 equals no x, a x is to the third there. We got a bx to the third, and plus c x to the thirds. Now let's look at x to the seconds. We got 6 of them, and over here we'd have a x to the seconds, and here we'd have no x to the seconds, and we get dx to the seconds. So a plus d has to come out to be 6, and x to the first, with no x to the first here, x to the first, we get 25b x to the first. So we get, x to the first up here is 100. 25b, and let's see, x to the first times x squared, nope, so that's all we got there. And then the constant, that's 75. And let's see, we get 25 a's. We get no b's because they both have x's, and the c's have x's, and the d's will have x's. So that's all we got. Well, this one turns out, since it's so thin, very few a's, b's, and c's, we can tell what things are going to be. For instance, this 75 equal 25a tells us a has to be 3. Let's do it with blue here, 3. This, move this up a little bit. If a is 3, d has to be 3, because a plus d has to be 6. And see, if 100 is equal to 25b, b must be 4. And if b is 4, c must be 5. Okay? So this integral changes to the integral of a 3 over x squared dx plus b 4 integral of 1 over x dx plus cx plus d, so we're going to have to write that together, 5x plus 3 over x squared plus 25 dx. This one is just let x to the minus 2. So we can integrate that one pretty easy. Adding 1 to minus 2 makes it minus 1, and we divide by minus 1, so we get negative 3. X to the minus 1 is 1 over x. And that's the first one. Plus 1 over x integrates to be ln x, so we got 4 ln absolute value of x. But this one's a little messier. So we're going to split this up into two fractions that sum in the numerator. So we're going to have the integral of 5x over x squared plus 25 dx plus the integral of 3 over x squared plus 25 dx. Now these, if you let u be x squared plus 25, du would be 2x dx. If you divide by the 2x, we have something to replace the dx, so we get the integral of 5x over u dx becomes du over 2x. So the x's cancel. The constants can be pulled out, so it's 5 over 2 integral of 1 over u, which is plus 5 halves ln of u, which was x squared plus 25 plus c, but we're going to get a plus c at the end here. So now we got to do this one. And that one is a little trickier. So I have an x squared plus 25. If it was x squared plus 1, be easy. So I'm going to factor a 25 out of the denominator forcefully, because there's no 25 in that x squared. So I'm going to write this as 3 over 25 integral of 1 over 1/25 x squared plus 1. You see how 25 times this would make x squared, and 25 times this would make the 25. And then I'm going to do a u sub, not an obvious one. I see 1 over 25 x squared as 1 x over 5 squared. That's what 1/25 x squared could be written as, because that becomes x squared over 5 squared. So I'm going to let u be just that x over 5. So du would be 1/5 dx, because x over 5 is 1/5 x. Multiply both sides by 5, and 5 du is what dx is. So I have the 3 over 25 integral of 1 over u squared plus 1, and dx is 5 du. This 5 is a constant, can come out and cancel one of the 5's in 25, so it leaves me just a 5. And the integral of 1 over u squared plus 1 du is arctangent, so I have 3/5 tangent of u, which was x over 5. Now, something you might want to notice here. There's an x squared plus 25, and all it did was create a 5 under the 3 and a 5 under the x. That's a pattern. And they show that pattern in the short table in the back. They said if you have something squared plus something squared, and use the variable, then you get 1 over the constant, which that we had 25, so that's a 5 squared. So 1 over the 5, and u over the 5, and the u is whatever was there. We had an x, and then we had a 3 in the numerator, so that's why we got a 3 over the 5 there. So you could have looked at this table and done that one. Okay. Now let's go to this one. This doesn't factor, this does, and so we put an a over the linear factor. This is a quadratic factor, so we do a bx plus c. And now let's figure out our a, b, and c's. So to get a common denominator, this one would have to be times x squared plus 9. And this would have to be times the x minus 4. So we have minus for the x squareds. We have minus 4x squareds over here. And we have ax squareds here and bx squareds here. And c doesn't create any x squareds, and so that's it. Now for the x's, over here we have minus 1. Over here we have no x's with the a. We have minus 4b x's, minus 4b, and plus c. And for the constant, we have negative 32. And over here we have 9a. And b times x times that, and bx times that will have an x on them, so there's not constants. C times the x is not a constant, but c times negative 4, so we got minus 4c. Okay, now you can do this linear combination, substitutions, whatever you want. I'm going to do this with my calculator. This is a 1a, 1b, 0 c's, 1a, minus 4, 0 a's, minus 1, minus 4 b's, 1 c, 9 a's, no b's, and minus 4 c's. So I'm going to go to second matrix, edit, A, it's a 3 by 3, enter, enter, and I'm going to put 1A, 1B, and 0 C's, 0 A's, negative 4 B's, 1 C, 9 A's, 0 b's, negative 4 c's. Then I'm going to second matrix, put in the constants. Second, quit. Second matrix, edit. I forgot to do edit. B, enter. It's a 3 by 1, and I got to put in negative 4, enter, negative 1, enter, negative 32, enter. Then I go second, quit, clear. We're going to go matrix A inverse. That's this x to the minus 1 button right there, times matrix B, enter, and it says A should be negative 4, B should be 0, C should be negative 1. So there's my answers for this. A is negative 4, B is 0, C is negative 1. So now I have to integrate this, so this becomes the integral of negative 4 over x minus 4, and I'm factoring out the negative 4, plus the integral of negative 1, so I'm going to take the negative 1 to the outside, over x squared plus 9 dx, and the antiderivative of 1 over x minus 4 is, and with a minus 4 on the outside, is minus 4 ln absolute value x minus 4. And once again, if you need help doing that, do a u sub equal minus x minus 4 in this, and you'll get 1 over u du, which is the integral of 1 over u is ln u. And this one, well, from what we just did on problem 4, you can do this one by looking at this short table of integrals in the back, and we have a squared, well, that's 9, 3 squared, so a is 3 in this table. A would equal 3, and the u is equal to x, and so it becomes 1 over a plus, minus, because we have a minus on here, minus 1 over a, which is 3, arctangent of u over a, well, u is x over 3, so x over 3, plus c. Now, once again, if it's x squared and a 9, the square root of 9 is 3, and so you just put whatever numbers on top over 3 arctangent of x over the 3. So if it's just an x squared, pretty easy to do if you learn that pattern. This is, and the pattern's described here as in A of the short tables. Okay? Now it says, for each of the integrals, it says use a system to find the partial fractions. And they describe in the book how to do that, but I would prefer you know how to do the partial fractions. So this is going to take a little more room than they give us there. So I'm going to do this on a separate sheet of paper. So for the first one, x to the third plus x plus 1 over x to the fourth minus 1 dx. And I hope you can recognize, can factor that denominator. It would be x squared minus 1 and x squared plus 1, and the x squared minus 1 factors to x minus 1 x plus 1, and the x squared plus 1 doesn't factor. So we have a linear factor, so we put an a over it, a linear factor, we put a b over it, and a quadratic factor, so we do a cx plus d, and we have addition between each of these, or integral of each one of them separately. So now we need to figure out the a, b, c, and d. So the a has the x minus 1, so it'd have to be multiplied by these two. Those multiplied would be x to the third, an x squared, an x, and a 1, plus x squared plus x plus 1. The b would have to be these two multiplied, which is going to be x to the third. We're going to get minus 1x squared minus x squared. Then we're going to get plus x and minus 1. And this cx plus d would have to be multiplied by these two, which was x squared minus 1 if you multiply them together. So, figuring out our a, b, c's, and d's. So the highest power is x to the thirds, and they have to be identically equal. We have 1 over here. So one of them has to equal, well, we've got a of them there, b of them there, and c of them there. So a plus b plus c must equal 1. X to the seconds, we have none over here. So the x to the seconds have to be 0. We have a of them here, minus b of them, and no c's, plus a d of them, dx squared. X to the first, we have 1 of them. Over here we have a of them, b of them, and minus c of them, and no d of them. Okay, and constant. We have 1 on this side as the constant. Over here we have to get 1. Well, we have 1a. We have minus b. And cx will never be a constant. And d times minus 1, so minus d. Now, I can put this in the calculator, 1, 1, 1, 0, 1, minus 1, 0, 1, 1, 1, minus 1, 0, 1, minus 1, 0, minus 1. But I'm looking at these, if I add these top two equations, in the top and the first and the third, I get 2 equals 2a plus 2b. If I add the second and the fourth, I see the d's are going to drop out. So I'd get 1 equals 2a minus 2b, and the d's would drop out. So I have these, and if I add these, I get 3 equals 4a and no b's. So a must be 3/4. It just happened that these are a nice enough pattern to get that. And if a is 3/4, 2 times that would be 6/4, and 6/4 is 1.5, and so I need another half to get 2, and so 2 times 1/4 would make another half, so b must be 1/4. So let's kind of check our arithmetic here and make sure. So let's go through and make sure all these work. See, if A is 3/4 and B is 1/4, C must be 0 to get 1. And if A is 3/4 minus 1/4 would be a half. So D would have to be a minus half to end up with 0. So I did that differently. Now I'm going to do it on the calculator just to check my answer. So show you that the calculator will do the same thing. So second matrix A, this time, I didn't press edit. Second matrix, edit A, and now I need a 4 by 4. 4 rows, 4 columns. So I got to go 4, enter, and then I got to put in that first row, which is 1, 1, 1, 0. Next row is 1, negative 1, 0, 1. Next one is 1, 1, minus 1, 1, 1, negative 1, 0. And the next one is 1, negative 1, 0, negative 1. Now my constants, second matrix, edit, B, and it's a 4 by 1, enter, and it's 1, 0, 1, 1. Second, quit. Second, enter. So A inverse B, enter. A is 3/4, B is 1/4, C is 0, D is minus a half. Okay? And we could do math, enter, and get them in fractions. Okay. So now let's continue with the problem. We finally found A, B, C, and D. What they're saying is you can go to Wolfram or whatever and ask it to find those things for you. But that's not that difficult to do. So we get the integral of A is 3/4, so I'll pull it out. Integral of 1 over x minus 1 dx plus B, bring us down. B is 1/4, pull it out. Integral of 1 over x plus 1 dx plus cx plus d. Well, fortunately C is 0, so we only have d, negative 1/2, which we can pull out. Integral of 1 over x squared plus 1 dx. And this is a fairly easy integral set of 3 to do. 3/4 ln absolute value of x minus 1 plus 1/4 ln absolute value of x plus 1 plus minus 1/2. And this is arctangent of x plus c. Okay, took me half a page just to do A. Now let's see if I can do B in a half page. Actually, I think B's going to take a little bit more, because whenever the degree of the numerator is greater than the denominator, you're not ready to do partial fractions. You need to get this degree in the numerator smaller. And you do that by long division. So we have x to the 5th plus x squared plus 3 divided by x to the 3rd minus 6x squared plus 11x minus 6. So x to the 3rd times x squared makes x to the 5th. So now I take this times all of that, and I get x to the fifth minus 6x to the fourth plus 11x to the third minus 6x squared. Now I'm supposed to subtract, so I'm going to draw the line and change these signs so I can add. So I've got to add all the like terms. X to the fifth minus x to the fifth, no x to the fifths left. We got 6x to the fourths. We got 11x to the thirds, negative 11x to the thirds. Almost missed my negative. And then we have 7x squareds and no x's in any of these, plus 3. So now we say x to the third times what makes 6x to the fourth? And that would be 6x. So I multiply 6x times all of these, and I get 6x to the fourth minus 36x to the third plus 66x squared minus 36x. We're supposed to subtract, draw the line, change the signs on these. Now I can add. The x and the fourths are gone. 36 minus 11 is 25x to the thirds. Minus 66 plus 7 is minus 59. X squareds plus 36x plus 3. Okay. X the third, we'd multiply by 25. 25 times that is 25x to the thirds minus, 6 times 25 is 150. X squareds plus 275x minus 150. We're supposed to subtract, so I'm going to draw the line, change the signs. Now I add, no x to the thirds. I have 91x squareds. Let's see, 75, 69, 39, minus 239x plus 153. Since x cubed won't go into this, there's nothing we can take, nothing nice that we can take times that to make that. And anyway, this degree is now less than that, so we put our remainder over our divisor and we write plus 91x squared minus 239x plus 153 divided by x to the third minus 6x squared plus 11x minus 6. So if we have to integrate this, we have to integrate that numerator, because that's what that divided by that is. So my problem changes to the integral of x squared plus 6x plus 25. I'm going to separate this into two pieces. That's a pretty easy integral to do, so I expect you can do that one. Plus the integral of this, 91x squared minus 239x plus 153 over x to the third minus 6x squared plus 11x minus 6 dx. Okay. So now, this part would become 1/3 x to the third plus 3x squared plus 25x plus, what do we get out of this? Well, first thing is we need to factor that denominator. Well, let's see how it factors by using the calculator. Turn it on. Y equals x to the third minus 6x squared plus 11x minus, subtract 6, not times the negative 6, zoom 4. Ooh, did I type something wrong? Yes, I did. Subtract. I did negatives and subtracts. Okay, graph. And it looks like it goes through 1, 2, and 3, which says the factors of this are x minus 1, x minus 2, and x minus 3. 3 nice, easy linear factors. You can multiply that out if you want and check. But anyway, this integral turns into an integral that will have a over x minus 1 plus b over x minus 2 plus c over x minus 3 dx. So now we're going to integrate this by parts. So a would have to be times these two, which is x squared minus 3 minus 2 minus 5x plus 6. B would have to be times these two, which is going to be x squared minus 1 minus 4x plus 3. And C would have to be times these two, which is x squared minus 3x plus 2. So, figuring out my A, B, and C, I'd have to do my x squareds, my x's, and my constant. The x squareds, I have 91 equals A plus B plus C. My x's, I have negative 239 equals my negative 5a minus 4b minus 3c. And that 153 is equal to 6 a's plus 3 b's and plus 2 c's. Okay. I just noticed something that's kind of nice about these. If I add all three equations, I get minus 3 plus 3 c's. C's are going to drop out. Oh, everything would drop out. Nope. The b's drop out, though. 1 plus 3 is 4, minus 4, they drop out. The a's, if I add them up, I get 7 minus 5 is 2 a's would equal these three added. So 91, let me add those. 91 plus negative 239 plus 153 is 5. 2a is 5, so a equals 2/5. And how to get the b's and c's, I'd have to sub them in, but I could put the 2/5 in here and move all that over and work on with that, but that's a mess. So I'm just going to let my calculator do all the messy work by using matrices. Second matrix, and edit A, and it's now a 3 by 3. 3, enter, 3, enter, 1, 1, 1, -5, -4, -3, and 6, 3, 2. Second matrix, edit B, 3 by 1, 91, -239, and 153. Second quit, second enter, second enter, second enter. A inverse B is, oh, it says different answer than what I had for A. I had 2/5. No, it should have been 5/2. I've got to divide by 2, so it's 5 over 2. So 5/2, which is what it does have. A is 2.5, 2 1/2. B is -39, and C is 127 1/2. Okay, so let's finish this one up. It's going to be pretty easy. We've already integrated this part. 1/3 x to the third plus 3x squared plus 25x. This is a linear factor, simple one, and it's 2.5 is the a, so I can pull it out. 2.5 times ln of x minus 1. B is -39, I could pull it out. Then I'd have the integral of 1 over x minus 2, which is ln of x minus 2 in the absolute value. And then I have this, which is on the numerator. I can pull that out, so it's plus 127.5 ln absolute value of x minus 3 plus c. Doesn't that look like fun? Aren't we having so much fun? Okay, and C. Okay, so we have, is that numerator factor? I don't think so. If it did and cancel one of the x minus 3's, it'd be nice, but it's not going to have an x minus 3 factor, so this integral, x minus 3 to the third dx is going to have to be, well, we have a linear factor 3 times. So this would change into a over x minus 3 plus b over x minus 3 squared plus c over x minus 3 to the third. So this one, we'd have to multiply by x minus 3 squared, which is x squared minus 6x plus 9. This one would have to be multiplied by x minus 3, and this one doesn't need to be multiplied by anything. So we get x squareds, x's, and a constant. X squareds, we have 1 over here, so we better have 1 here, which is a, and no b's and c's, so 1 equals a. Done with that, we know what a is. And for the x's, we have minus 1, and we got minus 6x 6 minus 6a, 6a x's, and here we get plus b x's. And since a is 1, this is minus 6, so we add 6, so we get plus 5, so b has to be 5. We've got most of this figured out already, and let's see what the constants tell us about c. We have minus 1 equals, we got 9 a's minus 3 b's plus c. So we have 9 minus 15, which is minus 6. Add 6, we get 5, and so c equals 5. Let's just check it, just because I don't want to make a mistake here and have you guys confused. So I'm going to go to my calculator, second matrix, edit 3 by 3, and I have 1, 0, 0. Negative 6, 1, 0. 9, negative 3, 1. Second matrix, edit B, and that is 1, negative 1, negative 1. Second, quit, enter, 155. So I don't think I made arithmetic error. So this becomes the a would come out, be 1 over this dx, which is just ln of absolute value of x minus 3. And all of these I would be doing a u sub. U equals x minus 3. du would equal dx. And so this becomes 1 over u du, which is ln of u. This becomes 1 over u squared, and 1 over u squared is u to the negative 2. To integrate that, I'd have to add 1, which becomes u to the negative 1 divided by negative 1. So it's minus u to the negative 1, which is 1 over u. And this, and we have a 5 from the b. The b is a 5, so I'll just put the 5 here. And we have a 5 for the c. I could put minus. Oh, the minus is because of the power. And then on this one, we're going to get a minus because we're doing u to the minus 3. So it'd be minus 2, so we get 1 over minus 2, so minus 1/2, and the constant c is a 5 over, and it becomes u to the minus 2, which is x minus 3 squared. Okay, so C wasn't as nearly as rigorous as B was. Okay, and now we've got to go to 7. Okay, now they're asking you to use the appendix and whatever else, so I'm going to kind of help you through that a little bit. So on this first one, if you looked at the appendix, see, where do I have that? Oh, that's right here. Do we have anything that sort of looks like that? Well, a square root in the denominator with some addition and another square, that kind of looks like, well, that's in the numerator. We want it in the denominator. So that's kind of like this, but we don't have a u squared in the numerator. We have something that looks more like this one, don't we? Oop, 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 oop. Slide it up. Let me see how I can show you that. Looks like this one, where u would be the 9x squared. So we would have to go, hang on, my computer just didn't let me see the problem anymore. Well, okay, I think we're all right. U would have to be the 9x squared. So I would have to let u equal 3x, because then u squared would be 9x squared. That squared would be 9x squared. So du would equal 3dx, and so du over 3 would be dx. So I'm going to change this problem to the integral of 1 over, that's an x. If it was a 3x, that would be a u. So if I make it a 3x, that puts a 3 in the denominator. So if I put a 3 in the numerator, that's still the same. So now I have u square root of u squared plus 5 squared. Du is 3dx, so du over 3, so I have to put a 3 in the denominator. I have a 3 in the numerator, so they're going to cancel. So now it looks like that, and so it becomes the integral of, or it becomes minus 1 over the a is 5, ln absolute value of 5 plus the square root of u squared, so that's 9x squared, plus 25 all over u, which is 3x plus c. Now let's make sure you can see that. I got to get my computer unlocked. Okay. Can you see that? I can't really tell for sure. Hopefully you can see that. So I was trying to follow this pattern. After I made u be 3x, then I put, instead of x, I put 3 and 3, so it's 3x, so I can make it u. And then the du had a 3 underneath it, which came out and canceled that 3. Or I could have just said that 3 went in front of the x and made a u. Anyway, and according to the rule, this is what we would get. So now let's look at the next one. All right, so the next one, we need to do something about this, this x to the fourth, because none of the formulas have an x to the fourth. So I'm going to let u equal x squared. So du equals 2x dx. And so I'm going to get a du over 2x for dx. And that's going to cancel the x. So this will become the antiderivative, the integral of x square root of 1 plus u squared, because x squared is x to the fourth, and dx is du over 2x. The x's cancel, and so I just have 1/2 the antiderivative of the square root of 1 plus u squared du, which according to the table, since that's what they want us to use, looks like I think that pretty much looks like C on the table. Hopefully that's in the right place for you, because it's they've got these reversed order here, but my A would be 1, my U is my U. I have a half, so I have 1/2, and then I get U, and remember U is x squared over 2 square root of u squared, so that's x squared squared, x to the 4th, plus a squared, well that was, this is plus, so I'm still using the top one only. It'd be plus 1, and I'm using the top one, so it's plus a squared, which is 1 over 2 ln absolute value of u, which is x squared, plus square root of x to the 4th plus 1 plus c. Yuck. Okay. The next one. Well, I think they want us to let, looks to me like we're going to get something squared plus something squared if we let u equal e to the x. Because then du would equal e to the x dx, and du over e to the x would equal dx, and so this integral would become, hopefully that's the right place here, would be e to the x square root of 2 squared plus, that's e to the x times e to the x, so that's eu squared, and dx is du over e to the x, and the e's to the x cancel, or if you changed them to u's, the u's would cancel, and so we have something that looks like the one we just did, which is a long, messy thing again. Let's write it down. So it looks like C again. So we get u, which is e to the x, over 2 square root of e to the 2x, that's e to the x squared, e to the 2x, plus a is 2 squared 4, plus 4 over 2 ln absolute value u e to the x plus the square root of e to the 2x plus 4 absolute value closed plus c. Yucko. But that's what they were expecting you to be able to do. Can you believe it? What are we going to do on this one? Well, this one I think I would let u be cosine of x, because then I would have u squared, and so I'd have 3 squared minus u squared, which is going to match 3 squared minus u squared, which would match this one, as long as the rest of that stuff would disappear. So let's see what happens here. So this becomes the integral, du would be, derivative cosine is negative sine x dx, so we get dx can be replaced with du over negative sine x, and so I'd have tangent, which I'm going to change right now to sine x over cosine x, and then in the denominator I'm going to have the square root of 3 squared minus u squared, and then I'm going to have dx replaced with du over negative sine x, and the sine x's will cancel. I get a negative on the outside from that negative, and this cosine x is u. So this becomes the integral of 1 over u square root of 3 squared minus u squared du. Does that look like some formula on here? And I'm looking, and it looks to me like it might be like J. So it looks like this will turn out to be 1 over, my A is a 3, ln absolute value of 3 plus the square root of 9 minus u, which is cosine u squared, so cosine x squared, over u, which is cosine x plus c. And that was D. Okay, so I think I've finished those. All right, so finish these. This one, something this complicated, U substitution is not going to work very well. You could try it, different things. Integration by parts this is not two things multiplied, this stuff inside stuff. You have this times 1 over x. You might use that, but it's not going to work out very well because that's too messy. And if you put it on an integral table, you won't find anything there, even if you have one of those really long, comprehensive tables. So I went to Wolfram and typed this in, and you can see it typed in there. The square roots, I did it to the half power. So I have 1 plus x squared to the half inside x plus that to the half, and so that's the numerator. And then the denominator was an x. So I asked Wolfram to please do this one. And what they wanted you to see is that sometimes even the technology says, I'm not sure exactly what that will be. Okay? Now, if I put it from 1 to 3 or something like that, my calculator could figure an estimate for the value, but what the antiderivative is not for sure. Let's see what the calculator says it is on a definite interval. Let's just look at that function. So I go to there, I clear, and I make a fraction. Alpha equals, enter. In the numerator, I have the square root of x plus the square root of 1 plus x squared out of that one, and that's the numerator. I believe that's what it was. And then in the denominator, we have an x, and if I go zoom 4, so it doesn't look like the graph is that crazy, and we should be able to find the area. If I wanted to find the area, like from, now 0 would be questionable because it looks like it's got an asymptote, but if I just wanted to find the area someplace, I'm trying to find a place where it's not so much reflection. If I wanted to find the area between 1 and 3, it says, oh, it can figure it out. We can come up with a decimal approximation. So if you ever ran into something like this, do decimal approximations. Or you could do left-hand sums or right-hand sums or whatever, and you could still get a value for a certain definite integral on it. But to come up with a function that's the antiderivative of that, not so easy.